water, if I put some drops of water on the table, if I put some water on the table, small drops of water on the table, after a certain time it will evaporate or not?
Yes, sir.
Is it undergo freezing possible at normal temperature?
No,
No,
sir.
sir.
Not possible. At this temperature, not possible. Otherwise, what happens? Physical form, if you observe, flow of water always from uphill to downhill, spontaneous process. Now, will you come to what chemical reactions? If I add acid to the base, the reaction readily takes place. Then, if I add HCl to NaOH, readily the reaction takes place. So, neutralization reactions are spontaneous. Combustion reaction, if you observe combustion reactions, readily they undergo. So if you just start that firing, combustion takes place continuously here. For that, what happened? No need any energy, just initiation is required. Initiation means it should catch the fire. You have to on that fire. So spontaneous reactions, examples, if I take what combustion reactions are spontaneous in nature. Neutralization reactions are spontaneous in nature. Now, what is spontaneity means? It is a reaction that takes place on its own without any external influence. They are called what? Spontaneity. So, neutralization reaction. Just you have to add acid and base. Just you have to add acid and base. Then the reaction takes place on its own without any influence. Can you bring back that salt into acid base better? Is it possible? For example, NaCl, when you add into the water, do you get acid, NaOH and water? Is it possible on its own? Impossible.
No, sir.
Because in your home, NaCl is there, salt is there in your home. Now put the salt in the water, do you get sodium hydroxide and acid? No. This will never happen. To get this one, we need some external force will be there. Externally, we have to add something to that one. So this is called non-spontaneous. But reverse is what? NaOH. Add HCl. Immediately we get NaCl plus water. Immediately we get this one. So this one is what? Spontaneous. On its own, if the reaction is taking place, they are called spontaneous reaction. Now we'll take some flow type of symbols. Flow chart we'll take here. Let me see this one. This one. Just a minute. Now here it is what? Gas A beta. Gas A. This one is the gas B beta. They are in different container. They are separated by using something, a piston, something. I have separated this one. Remove this one. Remove this one. Now everything is mixing. Gas is mixing. Now this is called diffusion. Gas mixing here. Diffusion taking place. Now nothing but a spontaneous process. For mixing the nitrogen, hydrogen, do you need any force? No. They are, you see, nitrogen, hydrogen, see, they are occupied here, everything. So this mixing of gases comes under spontaneity. Next, flow of water, you see. Water from where? Up to what? Downhill. Spontaneous process. Reverse करने के लिए आपको motor use करना है. So using motor is what? Non-spontaneous process. Now, if you observe what are the features for the spontaneous reaction, they are unidirectional. That means they are one directional. That means if the water is, if you observe here, water, be one direction only. Do they reversible? Is possible without consumption of energy? I'm saying, is it possible, beta? Can water go uphill? Anywhere you found that one? Anywhere water falls from down to up. Anywhere is there like that? Have you seen? Very rare case, one or two are there, but they are very rare case actually. 1, 2 are there, but they are very rare case. That is because of consumption of energy from the earth under the crust actually. They are unidirectional, irreversible. They are irreversible. All spontaneous processes are unidirectional and they are irreversible. You cannot bring back that. It is not concerned with the rate at which the process occurs. Okay. So what type of isn't it rate of in that case? So that we cannot consider. It is not concerned with rate. So rate means what? Speed. It does not depend upon the speed here. Based upon speed, you can't say that one. Right? Next, it proceeds till equilibrium is established. How much? For example, human body is there. Human body A, human body B. Two are there. Now he is having heat, temperature. He is having temperature something what? 40 degrees Celsius. He is having temperature something 36 degrees Celsius. When these two are connected, like this, they are joined like this. When these two are joined. Now what happens here? The heat always flow from high temperature to low temperature. High is 40 degrees Celsius, low is what? 36 degrees Celsius. So here heat is flowing from where? 40 degrees Celsius to 30 degrees Celsius. So this is what spontaneous process. If heat is flowing from 36 to 40, that will be non-spontaneous, because heat always flow from hot body to cool body, hot body to cold body. It will always flow like this, hot body to cold body. So that is happening. Up to what it will happen here? So that it will reach same temperature, so that both will get same temperature. So it proceeds till equilibrium is established here. So the flow of heat from hot body to cold body until an establishment of equilibrium took place. So both, whenever if they get same temperature, at that point what happened? The heat will flow like this. So that is the third point. All natural process can be taken as what? Spontaneous process. Right? All natural processes are spontaneous process. Now at the beginning, I told you what is the objective of thermodynamics, beta? What is the objective of thermodynamics? I told you. Anybody? What is the objective of thermodynamics, beta? Anybody knows that one? Are you there?
Yes, sir.
Tell me, beta.
Yes, sir.
What is the objective? Thermodynamics speaks about the spontaneity of the reaction. The major objective of thermodynamics is it speaks about what? Explain whether the reaction takes place or not. Spontaneity of the reaction. So that we are now explaining now based upon the entropy values. Right? Now discuss about again solid. In solid, what happened? You have seen the particles, maybe molecules, maybe ions, maybe atoms. They are what? How, isn't it? Orderly they are arranged. How disciplinedly they are arranged. You see, in solid state, they are arranged orderly. They are arranged orderly. Like you sit in the classroom. Your disorder is what? Very less. Disorder is almost all what happened here. Negligible. Very less. But in the liquid state, the order is changed now here. Converting into little bit disorder now. Now in this case, disorder increased here. That means you are sitting in what? In a in a meeting before starting an assembly. Before starting assembly, how you sit? What happened? Something what happened? The line we don't maintain. What do you sit? But line we don't maintain. But in the gas, what happened? Disorder will further increases, will have more disorder here. Very much high disorder. Like you are playing in the ground. When you are playing in the ground, we don't have any order. Nobody will sit in order when you are playing in the ground, isn't it? So gas molecules will have more disorder, less order. They are arranged less order. So now what I'm saying here, some solid to liquid, liquid to the gas, the disorder what happened? Increases. Now, what is entropy? Entropy is nothing but degree of disorder. Now tell me, which is having more entropy, beta? Solid or gas or liquid?
So gas.
Gas. So entropy means the amount of disorder or degree of disorder is nothing but entropy. And gas molecules will have more disorder. Now, you want to remember, you tell me, beta, you want to be in classroom or you want to in ground, where you will feel good?
Ground, sir.
Ground only. Why? Because what is the reason? In ground, what happen? You will be free. Okay. So similarly, what happen? Even the molecules also, particles also want to be in disorder. They don't want this type of isn't order actually. This type of discipline they don't want actually. They want to be in the free phase actually. So they want to first they want to convert into liquid. Liquid also they don't happy. So liquid they convert into gas. So every elements, every particles present in the atmosphere on the universe, they want to get disorder actually. Isn't nobody want in order, nobody want discipline. Isn't it? Here same thing like that. So that is the reason solid readily convert into liquid, liquids readily convert into gas molecules. Of course, they need temperature that is different actually. But conversion of gas, conversion of liquid, what happened? We have to supply some energy to that one. To make that one into order, I have to supply some energy. So what I mean to say is that if I increase if entropy is increasing, that is moving towards spontaneous. If entropy is decreasing, moving towards non-spontaneous. Now, solid to liquid, spontaneity will increases. Liquid to gas, spontaneity will increases. Gas to liquid, spontaneity will decreases. So, based upon spontaneity, we can predict the reaction. Whether reaction takes place or not. Yes, liquid, whether water converted into gas, yes, spontaneously. If I ask some question, water converting into gas, yes, because water, gas, possible, because entropy, what happened here? Increasing. So definitely it is possible. Spontaneous it is. You can say it is spontaneous. So based upon the entropy values, we can predict the reaction spontaneous or not. We'll discuss later actually. In detail, we can discuss this. Order, disorder, IG disorder state. So this is about the simple information about the entropy. The thermodynamic property which measures the molecular disorderness or randomness is called what? Entropy. Okay. This is in the form of some order type of definition. Orderly I have given the definition. Disorderly, if we say what happened? Degree of disorder is called entropy. You want to put everything right, that is called this formula. Everything is right. So if which is easy for you better, simply if you say degree of disorder is called entropy. Very simple it is. Because it's randomly I said here. Randomly I said is what? Very simple. If in the form of definition I have to say, what I have to say? The thermodynamic property which measures the molecular disorder randomness is called what? Entropy. So it's very difficult for us. Isn't it? Because it is what? We have to frame everything in terms of sentence, everything. Otherwise, simply say degree of disorder is called what? Entropy. Which one is simple? What happened? Saying what happened disorderly or simple. Similarly, what happened? Entropy, whenever it's increasing, it becomes very simple. The reactions becomes very simple. The reactions will take place in simple manner like that. But opposite what? That means entropy is decreasing. What happened? The reactions will not take place simple. Actually. Now, the formula of entropy, if you observe, the change in the entropy, when you rate, it relate to what temperature, then it is called what? Change in the entropy. But here, you have to consider in the reversible reactions. For reversible reaction, the heat you have to consider. Delta S is equal to formula is important better. You have to remember this formula. We'll get many number of problems about this one. Delta S means what? What is the meaning of delta S beta? S final minus S initial. Otherwise, S initial minus S final. S2 minus S1. S2 minus S1. For example, I will take one example to explain for you. I have taken ice converting into water. Ice converting into water. Okay. Now here disorder S initial, S final I have taken. Now disorder in the water will be more. And disorder in S ice will be less. Now substitute in this formula delta S is equal to what here? More minus less. Definitely we are getting a positive value. So delta S is positive for this expression. Now convert vapor into water. Convert vapor into water. The water will have S final will have, water will have less disorder. The degree of disorder, what water will be less. For vapor, it will be more disorder. Now, in this case, delta S will be what here? This S final minus S initial. Less minus S final minus S
Negative.
negative it is. Delta S is negative. So you are getting delta S is equal to negative. This process is non-spontaneous process. Non-spontaneous process. Now when you get delta S equal to positive, this is called what? Spontaneous process. So like that we can explain here. But when you take formula here, always formula delta S should be equal to Q by T. Q means what? How much heat is absorbed in this process. How much heat is absorbed in this process. That process must be in the reversible process divided by the what temperature. At what temperature this is taking place. For example, ice converting into water. What temperature beta? 0 degrees Celsius or 273.15 Kelvin temperature. Now 273.15 I will take as a T value. So how much heat here in this case absorbed here? You take something maybe from something to 36 kilojoules. You can just put that one actually. Next, the total entropy change for a process is always equal to system plus surrounding. Correct or universe you have to consider. Total entropy. Change in the entropy of system plus change in the entropy of surrounding. Then we get total entropy of the system. Now, if total entropy of the system is what? Positive, like this, positive, then it will be spontaneous process. If total entropy is less than 0, that means negative, isn't it? That will be non-spontaneous process. We got this for negative here over, no, like that. If total entropy is equal to 0, then you can say it is in equilibrium. It is in equilibrium. The system is in equilibrium, we can say. Right? So this is what very important for you. In examination point of view, greater than 0 means positive value. Less than 0 means negative value. Based upon these, isn't it? We can explain the spontaneity of the reaction by measuring the entropy, total entropy. We can say whether the reaction is spontaneous, non-spontaneous, or in equilibrium. We can easily explain. Next. Sign conversions. If you observe what happened, already we have completed this one. If disorder is increasing, we get a positive value. Correct or not? If disorder is decreasing, what we get beta? Negative value. Correct or not? In the previous slide only we have discussed this one. Previous slide we have discussed this one. This one only we have discussed. No. Here what happened? Disorder increasing. So what we got? Positive value. Disorder decreasing. What we got here? Negative value. Understood here? That I have taken. Example we are taking now. You see. Iodine, solid state, iodine, aqueous state. It is in order. This one is a disorder. Because in aqueous state, more disorder we get here. Now definitely it is a positive. That means spontaneous process. Hydrogen. Now tell me beta, both are in gas beta. Both are in gas phase. Now tell me which is having more disorder in this case? Molecule or atom? Molecular atom, which will have more disorder beta?
Atom. Atom.
Atoms will have more disorder because they don't have any bonds, no. In atoms, you don't have any bonds. That means attraction forces are not there in the atoms. So they are free. So definitely both are gases, order will have increases, order will have decreases and disorder will have increases. Right? Now delta S definitely will be positive. Now in this case, can you say compare reactant and product? Compare reactant and the product. Disorder entropy increases or decreases? For this reaction, for this particular reaction, entropy will increase or decreases better? Forward reaction. Increases only because, of course, solid is there. Of course, here solid is there. And here also solid is there. But gas you are getting or not? So definitely what happened? Disorder increases, positive only. This is the positive only. This type of questions you will get in examination better. Multiple choice questions. Will you say this one better?
Decreases.
Increases or decreases? Entropy.
Decreases.
Decreases. See, gas
Decreases.
into liquid. Decreases. Negative value I can write. Decreases means negative value. Both are gases. Here 2 atoms are there, here 6 atoms are there. So which will have more disorder beta?
6 atoms.
The disorder will be more, no. When you have what happened, more number is there, they will have more disorder. Number also you have to consider. But tell me the answer beta.
Randomness.
Randomness, very good. For this one, what will be the answer?
Equilibrium.
Spontaneous.
Next we'll see what second law of thermodynamics. Then we'll see the Gibbs energy also. What is second law of thermodynamics? Like this. First law already we discussed. Energy neither created nor destroyed, can transform from one form to other form. Second law, if you observe, heat cannot flow from colder body to hotter body on its own. On its own, heat will flow from where? Hot to cold. Heat generally will flow from hot to what? Cold. This is generally happens. If I want to do cold to water, hot, cold to hot, compulsory I have to apply some energy over it. You are making, isn't it? Cold to hot. I would heat this one. I would heat this one. Without heating, it never takes place. Understood better? So, second law of thermodynamics saying that this never happens unless if you apply some work on that one. Heat on. That means you are doing on that one. Heat cannot flow from colder to hotter body on its own. On its own, it never takes place. Similarly, you can say what happened. Water does not flow from low to what? High. All spontaneous processes are thermodynamically irreversible. Just now I told you this one, no? All spontaneous processes are not at all reversible, they are irreversible. Just now I told this one. Can you bring back this one? On its own. Can you bring back this one on its own? Impossible. On its own, it never takes place. For reversible, you have to apply some heat over this one. Okay, all spontaneous processes are thermodynamically irreversible. They cannot be bring back. And entropy of the system always will increases. For example, see entropy of the system. That means what happened? Liquid is what? Solid is what? Converting into first. You see something. What? Ice. Converted water. Entropy increased or decreased better? Ice conversion of what? Entropy increased? Increase. Now again, water
Increases.
convert into vapor better. Water will convert into vapor. Again, entropy is increasing, here to increasing, here to is increasing.
Yes, sir.
That means entropy of the universe, isn't it? Always remains constant, but entropy always what happen? Increases here. Next, it is impossible to construct a machine. It is impossible to construct a machine working in cycles and transfer heat from low temperature region to high temperature region without intervention of external source. You cannot construct a machine which works, isn't it, from heat flowing from where? Cold to hot condition. Heat is flowing from cold to hot condition without using some external source. It is impossible. By using some electricity, whatever you use electricity or whatever it may be, you can convert heat flow from where? Cold to hot. So what they are saying, we cannot construct a machine which will works in a cycle in which what happen, heat is flowing from lower temperature to higher temperature. This cannot be done without using any external source of energy. Understood here? So this mission cannot be perpetual mission, generally we call this one. Next, if you observe what happened, Gibbs energy, it is the free energy of the system to do the useful work better. If you want to do, any system is something about doing some work, what happened? Whatever the energy using for what? For useful work. Then that energy you are calling as what? Gibbs energy or Gibbs free energy we can call this. It's a state function depend upon initial and final, but not on the path actually. It depends upon initial final states, but not on the path. Which one? Gibbs energy G. Now can be represented by G can be represented by H minus Ts beta. G is equal to H minus Ts. Now what is H? Enthalpy. You know this one. T means temperature. What happened? Entropy. You know this one. The change in the Gibbs energy given by delta G beta. Change in the Gibbs energy. Delta G is equal to G2 minus G1. G final minus G initial. Because it's state function. Now apply this one for this one also. Temperature H, delta H. For entropy also substitute this one. Now delta G is equal to delta H minus T into delta. This will be a constant temperature. Now this is the formula we have to remember. This is the formula to calculate the delta G formula. So remember delta G is equal to delta H minus T delta S formula is very, very important for us. This is called Gibbs-Helmholtz equation. Now, let us discuss again the total entropy always equal to entropy of system and entropy of surrounding changing at constant temperature and pressure. Okay, at constant temperature and the pressure. Constant temperature, heat change can take place. Okay, heat content of the reaction at constant pressure. Okay, what I'm taking QP. Okay, if we maintain constant temperature, heat can flow. It can change. That means heat can change here. When heat can change at constant pressure, that is called by QP now. Heat can be called as QP. So now what I'm writing, delta S formula already you know that better. Q by T, no? Just now I told you what is the formula for delta S? Q by T reversible, I told you. Something right. So formula that I'm taking here, both the case actually. Got like this. Okay. Delta S for this one. Surrounding. Delta Q surrounding is equal to what? Correct or not? Otherwise, I will just revise this one. Just now. Now here, surrounding, if for example, if surrounding is releasing heat, who will gain beta? System. If system is releasing heat, surrounding will gain. Correct or not? If system is absorbing the heat, surrounding will lose the heat. So values will be same, the sign will be different. If, for example, system absorbing heat, so system gets a positive value. The surrounding releasing the heat, surrounding will get a negative value. So what I am writing here, the heat exchanging total is always equal to system plus surrounding, but system is equal, surrounding is equal for this one. For surrounding, if it is a heat QP, for system definitely it will be in minus sign. So the amount of heat I am writing in the form of delta H. Now these two will be what for system? This is for system. Q is nothing but what? Enthalpy only. Enthalpy for system. But delta S equal to what I can write here? Q reversible by T. This already we discussed that formula actually. This is the formula for entropy. Now what we can write? Entropy of surrounding. This one. Entropy of surrounding. What we can write? QP by surrounding. Okay. You put delta S equal to what is the formula? Q by T. Now delta S surrounding is equal to Q surrounding by T, but temperature is constant. Temperature I have taken constant here. So therefore, delta S equal to Q reversible by temperature. Then delta S surrounding is equal to Q at constant pressure. Q at constant pressure for surrounding divided by temperature. Now substitute this formula over here. What we get here? This formula. This is for what? System. This is for what? Surroundings. System is something like this. This one we are solving. This one. This is for here. This is for here. Now what we get here? In the place of surrounding, I put this one. In the place of surrounding, isn't it? I have taken this one. And multiply this one with the T now. Multiply this one with T now here. What happens here? Now we get delta S into T. T delta S. Now T get cancelled over here. Now what we are going to get here? This TDS, because you are multiplying this TDS and delta T get cancelled. Here we get a TDS here minus delta H. Correct or not? TDS is equal to TDS system minus delta H system. You are going to get like this. This is the equation you are going to. Right? Otherwise, you can write delta H total into T is equal to T into delta S minus delta H by T into T. This T get cancelled. The remaining I'm writing over here actually. This is delta H. Right? I'm multiplying with minus equation. Just minus, they multiply this one with minus here. So minus T delta S we get here. That is equal to minus T delta S plus delta H we are going to get. We are going to multiply this one with minus. This minus will become plus here. This plus becomes minus here. And this plus become minus here. Now, minus T delta S is equal to, you can rearrange this one, delta S system minus T delta S system. In this way, we can write this. Send this one over here and this one. But according to Gibbs equation, what is the Gibbs equation? This one, delta G is equal to delta H minus T delta S. Correct or not better? Delta G is equal to delta H minus T delta S. Now, here also we got delta H minus T delta S. Now, in the case of this, I can put delta G formula over here. So, now delta G is equal to what we get better? Minus T delta S. Now, delta G is equal to minus T delta S. Now, for sign convention, if I take what I have? Spontaneous. Delta S must be positive. Correct or not better? Delta S must be positive. If delta S positive, what we get? Delta G value becomes what better? Anybody? If delta S equal to positive.
So negative.
Negative. So delta G you're getting negative. That means if delta S is positive, what we can say? Spontaneous process. Correct or not? Then if delta S is positive, spontaneous means delta G will be definitely what happened? Negative. So I can say delta G is equal to negative or delta S equal to positive. Both are what actually? Spontaneous. Next, for non-spontaneous, delta S will be what here beta? Less than 0. Means what? Negative. Now put here negative, what happened? We get, what value we get better?
Positive.
Will be, delta G will be positive. So when delta G is positive and delta S negative, delta G is positive and delta S is negative, definitely it will be non-spontaneous reaction. Finally, at equilibrium, delta S equal to 0. If I put here 0, what happens here? This value, if I put 0, what happens? Delta G will be also will be 0. Therefore, it will be equilibrium. So, based upon this, delta S and delta G, we are predicting the reaction whether they are spontaneous or non-spontaneous. Now, there will be effect of temperature is also there that I will discuss tomorrow because it takes some time actually. Okay, so it will take some time. And Monday, we'll do the remaining topics and the problems. Whatever the remaining problems we are having and the problems we'll discuss on Monday. You have class now? 10 o'clock?
Yes, sir.
Okay, good.
Excuse me, sir.
सर नहीं है क्लास में
तो अटेंडेंस
क्लास लीडर कोई स्क्रीनशॉट लेके रख लो, जितने बच्चे क्लास में हैं उसका।
बोला क्या सर ने वैसा?
पता नहीं, अभी तो सर नहीं है ना क्लास में, तो अटेंडेंस कैसे लेंगे?
सर गलती से लीव हो गई।
सुमित लिया क्या?
सुमित भी नहीं है।
मैंने लिया है।
फिर लीव कर सकते हैं?
सर के आने का वेट करो एटलीस्ट। क्लास है आगे अभी।
नहीं, अभी बायोलॉजी वालों का बायोलॉजी है बोल के सर ने खत्म कर दिया क्लास।
वही इसलिए पूछा था। अटेंडेंस लिया है मैंने। लीव कर लो तुम लोग।
सर ने नेम का लिस्ट स्क्रॉल किया था ना?
वहीं पे रुक गया था मेरे लिए तो, स्क्रीन स्क्रॉल कुछ हुआ नहीं था।
एक शायद से सर का कुछ नेटवर्क इशू होगा।
सर वापस आए तो तुम लोग बोल देना कि गर्ल्स क्लास लीडर ने अटेंडेंस ले लिया, उसकी बायोलॉजी क्लास है, तो अभी जितने भी बायोलॉजी वाले स्टूडेंट्स हैं उन्होंने लीव कर दिया, ठीक है?
ओके। अभी हमें लीव करना है या नहीं? मेरे को नहीं लगता सर आएंगे।
लीव करेंगे सब।
सब लीव
कर दो
करो।
लीव।
करो लीव करो।